This is lesson 7.2. We're talking about similarity transformations. Let's get right in it. Number one, can you recall a rigid motion? I'll give you a couple of hints here. It starts with a T, an R, and an R. Okay, see if you can write something down for that. All right, hopefully you got one or two of those, or maybe all three. We also want to know what the definition is for a rigid motion. Hopefully we recall that a rigid motion preserves both shape and size. Okay. In number two, now we want to know what were those transformations that make rigid motions. The T stood for translation. One of the R's stood for rotation, and the other R stands for reflection. Okay. Let's jump down to number three. It says, below is an example of a dilation that was taught in 7.1. We stated that dilations have the same shape, but different what? Well, take a look at the picture. You have triangle ABC, and then you have another triangle, A prime, B prime, C prime. You can clearly see that they are the same shape, but they have a different size. So let's write that in our notes. All right. So this dilation is an example of what we call a non-rigid transformation. All right, moving right along. We have an example here, graphic composition of rigid motions and dilations. In the example on the left, they're asking us to graph the image of ABC after a dilation of 0.5, followed by a reflection over the line x equals -3. So we'll start with this dilation of 0.5. Another way of thinking of that is that we are going to get half as big. So we're either multiplying by 0.5 or dividing by 2. Okay? They did not mention a center of dilation, so we will assume the center of dilation is at the origin. With that being the case, I'll probably go straight to the coordinates, and I'll look at coordinate A. I see that his coordinates are 2, 4, so I just want to divide them by 2, or I want half of those numbers. So my x of 2 becomes a 1, and my y of 4 becomes a 2. So my new point will be at 1, 2. That'll be a little A prime there. Okay. If I go over to B, I'm at -2, 8. I want to divide both those guys by 2, so I'll end up with -1 and 4, and I'll plot that point right here. That'll be a little B prime. And finally, C is at 0, 10. So he's going to be divided by 2. 0 divided by 2 is just 0, and 10 divided by 2 is 5. So I'll end up at 0, 5. All right, that'll be my C prime. And the second part of this question asks us to reflect it over the line x equals -3. Hopefully we recall that x equals a constant is actually a vertical line because all values of x, in this case, are -3. So let's draw in that line of reflection right there. And then we're going to take this image that we created over here of A prime, B prime, C prime, and we just want them to hop across that line. So if I look at A, and I count the spaces to the line of reflection, all right, I've got 1, 2, 3, 4, and I want to continue the same distance. 1, 2, 3, 4. So that'll be my new A. Okay. And B, count him to the line of reflection. 1, 2, so I'll go 1, 2 on the other side of the line. And then C is 1, 2, 3, so I'll go 1, 2, 3. And I will graph that guy, draw that little triangle. Okay. This becomes A double prime down here. Oopsie. This becomes B double prime and C double prime. So he got smaller, and then he did a little reflection. That is a composition. We have put together a couple of motions. Let's jump over here to the problem on the right. We want to describe a composition transformation that maps triangle XYZ to JKL, and the statement says that these triangles will be similar. So if they are similar and not congruent, their size is going to change. We can see that in the figure. Okay. with a quick look at this guy, if I were to think about it as a reflection, right, x would go to j, and then y should go to k. But when I look at it, if I reflect it over some kind of line such as this, y does not go to k, right? In this picture, y goes to L. So it's not a reflection. So let's get that out of our minds. All right. Another possibility is that it could be a rotation. It appears to be a 180-degree rotation. All right, so we're going to take all of our original coordinates. X is at 2, 1. Y is at 1, 4. And Z is at 4, 1. And if I do a 180-degree rotation, everybody stays at home, but we change their signs. So my new x becomes -2, -1. My new y becomes -1, -4. And my new z this guy's not working for me. My new z is, there we go, becomes -4, -1. So I can plot those points. I'm going to plot them in green. -2, -1 right about here. -1, -4 right about here. And -4, -1 right about here. I'll draw this little triangle out very badly. I got a shaky hand. Okay. Shapes look the same, so it appears that I need some kind of dilation. I'm going to take a look at this x coordinate. He's at -2, -1, and x needs to go over to j based on my similarity statement. So where was j? J appears to be at -4, -2. So how can I get from x to j through multiplication? It looks like if I just multiply everybody by 2, my scale factor is 2. And I'll get there. So I'm going to do that with each one of these guys. And there he works. -1 times 2 would give me a -2, and -4 times 2 would give me a -8. That's coordinate y. He's going to match up with coordinate k. Here's k at -2, -8. So it looks good. Okay. So to describe this composition transformation, we would say that we have a rotation of 180, doesn't matter positive or negative, followed by a dilation scale factor 2. That's it.